Okay, welcome back. We are still in section 7.3, which is integration of rational function using partial fractions. And as we said before, the rational functions are functions where they have numerator and denominator, and both of them are polynomials. So it is polynomial over another polynomial, and the denominator, usually the denominator should has power or degree more than the numerator. Otherwise, there is a step. We didn't do it in the previous example, but we will see it at the end of the lesson. Now, if we recall the steps, we have several steps we need to take care of. The first step is step 0, which we will not do it because our degree of denominator is larger, so we don't need this step at this point. Step number 1, we need to factor the denominator completely. And then we need to write the partial fraction. And then we do need to find the constant. And finally, we find the integration. So let's factor first. And we have to factor completely. Means as much as we can, as much as it's possible. So it is 1 over x squared plus x power 4. Now, if you take x squared as common factor, okay, then we have 1 plus x squared. And now, if you look at this one x squared, which is fine, we cannot factor it anymore, it's just x by x. Now this one, can we factor it? Maybe yes, maybe no, but how do I know? We need to go back to the quadratic equation. Remember, this is just a quadratic polynomial, which has the form ax squared plus bx plus c, something of degree 2. Now, go to your calculator and do for me mod 5(3). If you do mod 5(3) in your calculator, the calculator will ask you for the value of a, you will write 1, the value of b, the number in front of x, because I don't have anything in front of x, this would be 0, and finally the number without an x, which is 1. If you do this in your calculator, and if you get a complex number, which is, you will notice in your calculator the answer has an I, this means, which is definitely means we cannot factor this one. If we cannot factor it because we get a complex number, usually we call it irreducible quadratic equation. So I hope that's clear for everybody. And that's how we know if we can factor or not. We use mod 5(3). Now, how can we do it? The partial fraction. Again, because we have, now what do we have? We have two things here. I have irreducible quadratic, which is this one. And here I have, this is actually x minus 0, but it has been repeated 2 times. So actually what is inside is just a linear factor. But it's repeated 2 times. That's how we do it. So we have 2 things here. As a summary, we have a linear factor, but it has been repeated 2 times. We have to take care of this number 2. And we have irreducible quadratic, which is only 1 times, but it's irreducible quadratic. How we can do partial fraction if we have linear factor 2 times? Because we have 2 times, we have to write it 2 times. The first one, you have to write it as only x, because it's x to the power of 2, and the second one will be x squared. So that's how we do it. Because it's repeated 2 times, we have to write it 2 times, but the power will be increasing 1 by 1. If it is x power 5, this will be x squared, x3, x4, and x5. It will be just more than what you need. So this would be x3, this would be x4, this would be x5. And then, because we have an irreducible quadratic, this will be 1 plus x squared, and it's only repeated 1 time. Now, if you remember from the last lecture, we said if we have linear, what we write here is just a number without an x. So I will just go ahead and write a, and again, remember, this is linear, this is x minus 0 squared, so I'll just write another number, which is b. The third one, because this is quadratic, you have to write something like this: cx plus d. Those are the 4 things that you need to do. So this is how we do the partial fraction for this question. Okay, so it is simple as this. And now the next step is we need to find the constant, and then we need to do the integration. So let me go to the next page. Let me do the integration. Keep in mind I have a, b, and c, and d. Later I will come back here to find the constant. So let's keep the constant for a later. For now, let's just do the integration. So remember, I need to find the integration of 1 over x squared plus x4 dx. And I wrote it as a over x, b over x squared, cx plus d over 1 plus x squared dx. Now, just for simplicity, let me split c and d. I don't want them to be together. So I will get cx over 1 plus x squared. I will go d over 1 plus x squared, and then dx. Something like this. And now let's do each integration separately. I remember, take the constant outside. Let me also take the constant, because it doesn't matter the constant actually. So this will be a integral of 1 over x dx. This is very easy. Plus b integral of 1 over x squared dx. Plus, take the c outside. This is x over 1 plus x squared dx. And oh, finally, I just need to squish it here. D integral of 1 over 1 plus x squared dx. Let's do each integral separately. The first one is the easiest one. It is ln absolute value of x plus b. Now this one, if you remember how we do it, this I will write it as x to the negative 2 dx, and then I will add 1 to the power. It will become negative 1, and I will divide by it. So it will be x to the negative 1, and then if you divide by it, there will be a minus here. Now this one, again, I think you remember it. This is kind of a function, and the derivative is here. So I will use the u substitution, u equal 1 plus x squared. And this is a kind of a function and its derivative. So the final answer will be just c over 2 ln 1 plus x squared. You can check it at home that this is the correct way of doing this question. The final one is just use u equal tan theta, and this is just the normal tan inverse of x plus a constant which we don't know and we don't care, c prime. The final step, we need to find a, b, c, d, and we write them down as the final answer. So this is how we do it, and I wish that you are following up with me. It needs a little bit of practice, so please go to the online homework and practice it by yourself. Find how much the answers that you will get, and let me know if you have any other questions. Now what I will do, I will go back to this example up here, and I want to find the value of a, b, c, and d. Now, if you remember, we will do this exactly the same thing as we did before. We multiply everything by this one. So just let me go here and let's do it. Equal to 1 over x plus 1 over x squared plus cx plus d 1 plus x squared. Now this one will be x squared 1 plus x squared, x squared 1 plus x squared, and finally it will be x squared 1 plus x squared. That's how we do it. Now we start doing cancellation. Cancel with cancel. We cancel 1x with 1x. X squared would cancel with x squared. 1 plus x squared would cancel with 1 plus x squared. And finally, this is what we would get. We'll get 1 equal. From here, over here, I think I forget to write a and b. Now from here, I think we get a 1 plus x squared plus ax, sorry, b 1 plus x squared plus x squared cx plus d. Now you need to find for me 4 numbers for x, because I have 4 constants. I need 4 numbers. So let's choose a good values for x if we can. Remember what we did last time? We said we look at the value which will make this one equal to 0. But this is, we said it will never be 0. You can try it at your calculator, mod 5 and you will never find something make it 0. How about this one or this one? So we substitute x equal to 0. If we substitute x equal to 0, 1 on the left side, this will be cancelled. Boom. This will be cancelled because here will be 0. And this will be 1 plus 0, which is 1 times b. So we find the value of b to be 1. Good news, we know what is the value of b. Now we have to find another value of x to substitute with. And that could be a little bit tricky. So we could substitute x equal to 1. So on the left side, I get 1 equal, or I think it's easier not to substitute any value. Might be taking a little bit long time since we don't have any concrete number. Now what I will do, distribute this one here, and this one here, and this one here. Tell me what do you get. On the left I get 1, on the right I get ax plus ax cubed plus b is 1, so it is 1 plus x squared plus cx cubed plus dx squared. Take the numbers, that are similar to each other. So I have ax. Now take something with x squared and something with x cubed. X squared, I have 1. X cubed, I have a plus c. And here I have d. And finally, I have this one here. So it is plus 1. A little cancellation left and right. Give me this one. So ax plus 1 plus dx squared plus a plus c x cubed. Now, I think you can tell me exactly, because this is 0. So this must be 0. This must be 0. And this must be 0. And simply, what do we get is a equal to 0, d equal to -1, and c equal to 0. And that's how we find the constants, by comparing the coefficients. Okay, thank you so much for watching, and we will solve more exercises, 2 more exercises in the next 2 videos.